Okay. Today our plan is next. I'd like to discuss with you classification task in machine learning. Also, we will consider logistic regression algorithm. Some metrics for classification problem, and one of the central topic of our lesson is Pytorch. It's a very important framework for machine learning, and today we will try to write our first model with helping this tool. Okay, what is the classification task? We discussed previous time that we have a problem regression when we want to predict some continuous values, but also we often faced to classification task, and yeah, we have our features. We want to map there with some labels, and which they which often tasks we can define in this task. First task is when y 1 or 0. It's the binary classification when you have only two classes. And for example, when we solve problem fraud detection, when you catch some operation in the bank and you want to define it's is it fraud or no. Next example is credit scoring, when we want to define can we give the credit some for some person, or it's a very big risk for a bank and for us. And many examples binary classification. Next case when y is some values, some classes, and we have k classes for our tasks. Our task. For example, we want to classify some documents, and you have 5 topics for your classification. When you work with the specific document, you want to find, is it a political topic, or maybe animal topic, or maybe I don't know, machine learning topic, and you have k classes for your sample. And third case is multi-label classification. What is it? For example, when you use YouTube and you have some video, you can notice that under this video we have text. And for one sample, we have many tax, because for example, you want to consider some restaurant, and you want to understand which dishes in this restaurant, and for every restaurant you can create oh, I don't know, for example, 5 labels which define um, kitchen for this restaurant. And in this case, you just have key labels, for example, street food, vegetables, fruits, and others. And for our every sample, you can predict a few labels like predict. Okay, um, let's try to define metrics for a classification task. I think you can be familiar with precision metric. Sorry. Okay, just precision when we have true positive prediction, and in the denominator we have true positive plus false positive. Also, we have recall when we have true positive divide on true positive plus false negative. How it remember, when you want to define which right sample really right, and you define it correct, you need to use precision, because true positive is I think I can draw some. For example, you have two classes, is those classes, and you have the second classes. And when you it's positive and it's negative. True positive, it's when you say that this class positive, and it's really true. When you use then you predict negative, and this prediction is true. Sorry, true positive, true negative. And we have cases when we say that our class is negative, but in really situation it's positive. And when we say that our class positive, but in really situation it's negative class, and we can write I don't know, it's positive, but we say that it's negative. I think, and 1 second, I try to understand. Okay, false positive, and when you say that it's negative, but in real situation is positive. I think it's a strange situation with colors, but I hope that you understand me. And with these values, we can define our metrics, precision and recall. Also, we have F1 metrics, and it's just precision recall divide to precision plus recall. Also, we have ROC-AUC curve for estimate our model in classification task. Tell me, please, do you know about ROC curve? Dear students. Okay, what is ROC-AUC curve? You have x. Oh, okay. You have two axes, and for this x axis, it's false positive rate, and for this y-axis, it's true positive rate. What is the true positive rate and false positive rate? True positive rate is true positive divide to true positive plus false negative. For FPR, false positive rate is false positive divide to false positive plus true negative. Is the same values from this case. And you can notice that true positive rate, it's the same thing like recall, but in other context. And how we can build our ROC-AUC curve. I think you saw this early. It's just some step, and you want to estimate this squared under the curve, how it's built. For example, you have a few samples, 1, 2, 3, 4, 5, 6, 7. You have target, its real value for this sample. Or for example, 1, 0, 0, 1, 0, 1, 1. And you have a predicted value from your model. It's, for example, 0 0.9, 0 0.8, just, yeah. In this case, you need to sort your samples where height value is probability to predict first class. 0.9 means that with probability 90%, your sample from first class. And analogical, if you want to predict probability with your sample from the second class, you need to just 1 minus probability y y equal first class. And what you need to do next, you have some sorted list, and you need to fix some values. For example, when you will think that your sample is first class. What I mean, for example, you predict that your sample from first class with probability 80%, but it's doesn't mean that your sample really from this class. And maybe you want to choose other border value started from this. You will consider your sample like a first class. Do you understand what I mean? Guys? Okay, I'm afraid of this quite, but okay. Value that you can choose, it's just some limit, some threshold, and you decrease your value of limit, and on every iteration choosing your limit, value limit, you need to calculate this value, true positive rate and false positive rate, because on every iteration you can calculate precision recall, true positive rate, false positive rate. For example, if we choose our limit 90%, it means that our sample number one from first class in really situation, and we predict that this sample from first class with probability 90%. It means that this prediction is true positive, because we say that it's positive first class, and in real situation it's also first class. And you just choose your limit and make the point on your graphs, and next you get some curve which define your estimating for model. Okay, it's information about metrics for classification task, and now we can consider logistic regression algorithm. You can notice that it's regression. Why logistic regression algorithm for classification task called regression? It's really simple explanation, because you in classical regression, you predict some values from minus infinity to plus infinity. And you want to some function which map this interval to 0 to 1 interval. And if you notice that probability for different classes when you solve classification task. It's interval 0 to 1. And if you create some function which mapping these values to these values, you just create algorithm for classification task. And our function for mapping this interval with this interval, it's sigmoid function. What is it? Sigmoid function work like plus exponent minus x. And if you draw this function in 0, it's just, and if you draw it in, oh, sorry. Yep. In infinity, if you use infinity like argument for your function, you get values 1. If you try to use some value from minus infinity, you get value very like 0. Okay, it's sigmoid function, and you see that this value start from 0 and finish in 1. You want to use it like probability in classification task. So if you remember, previous time we considered that our prediction y is some feature matrices multiply on weights plus some b. And if you some change this function, you can get something like sigmoid function from this linear model, logistic model. You just apply some non-linear function for make these values from linear regression from this interval. And yep, it's just linear regression, but with non-linear function for mapping these values to 0, 1 interval. You can ask how it works in classification task. Okay, let's imagine that we want to classificate fraud detection like I said above. And we have feature matrices, we have weight vector, and you just calculate this value. And for example, you have sample 1, 2, 3, 4, 5. It's your transactions. And you get value, for example, 10, 20, 5, 25, and 40. And now you want for this value apply sigmoid function. On next step, you get some values. Oi. Yep. And it will some values from this interval. For example, 0 0.1, 0 0.2, 0 point, I don't know. And yep. And with helping these values, you can make you can predict class for your samples. For example, with the probability 50%, your fifth transaction from fraud class. Do you understand how it works? Maybe you have a question? No question. Okay. I think we can consider Pytorch framework for our task, and we can turn back to our notebook. What is Pytorch, and why we can we will consider it today? Pytorch is a very important framework for machine learning because it has some automatically differentiation in its functions, and for effective calculating gradients in learning process for our model, you can use it and optimize our calculations. For example, if you want to make it with helping NumPy, you will do it manually, but you want faster and more efficient in learning your model. Also, for GPU calculations, Pytorch only these abilities also in Pytorch framework, because it's also speeder and you want to make your calculation faster. So, for example, NumPy don't have these abilities. If we speak about calculations, I can talk you about computational graph. In Pytorch, it's a dynamical structure, and you can choose this structure during calculations. For example, in TensorFlow, okay, in old versions, TensorFlow, it was statistical computational graph, and all operations must be defined before launch your program. But Pytorch is a really flexible framework for your researchers and for your experiments. Okay, what about operations in Pytorch? To be honest, many operations almost the same like in NumPy, but you need to remember some operations from Pytorch. For example, when you call shape function from NumPy or multiply matrices, in operation, you use NumPy library, but when we want to apply torch, you need some change your functions, and you can make sure that this result will be the same in both cases. Yep, you can consider some functions and look and see difference between NumPy and Pytorch syntaxes. But yeah, I create some cells with these transformations. Really simple mathematical functions. I'm sure that you can write it own, but I think we can write it fast. You need to call Pytorch and call cosinus function. And copy this string, but changes function. Okay. I think we can launch this cells. It will, yeah, really beautiful image. You can change these parameters and play with the image, and we'll see how it changes. What about automatic gradients? I said that in Pytorch, you can automatically calculate the gradients in learning processing. Okay, in this example, we want to generate some synthetic data, and you can see that it's squared function, and you want to approximate this function in first case with the linear regression algorithm. I think that you see that approximate some squared function with helping linear function. It's a really strange situation, but you can see result after learning of our model. I want to show you some thing. 1 second. Yeah, you generate synthetic data, and in this cell, you define linear function for prediction with the linear regression. Initial predicted without calculating the gradient, and when you call grad function from Pytorch, you can see none because you don't learn your model now. But if you call function loss backward, you can calculate gradients, and I think we can run this code. And yeah, in real time, we can see how calculate our weights and how linear model try to approximate our squared function. And yeah, you have a really big loss, but it's non-optimal approximation for this task. And in this code, we want to implement some nonlinear regression for approximate our squared function. And I want to say that you need to normalize your data, because when you learn your model, you can face to problem exploding gradients, and you just you will discover that at the end your value for weights is very high, and Python will show just none, because this value really like the same like infinity, the same like infinity. And you want to decrease these values, and you want to use normalization with for solving this problem. And yeah, it's the same data. You also have a squared function, but in this case, you will use non-linear function, and you want to approximate your squared function, non-linear function, but squared function, it's some parabola. And so you can use some squared function for approximating your data. I want to say some things about calculating the gradient. When you calculate your values, you need to use grad 0.0, because if you, for every iteration, doesn't update your gradient, you just create cumulative sum for your mistakes, and it's really often a mistake for learning model. Every iteration, you need to clear your gradients and calculate again. Let's see our nonlinear approximating. I choose learning rate 0.001, take our squared function, and call function for calculating our gradient. You can see gradient descent, and changing our weights with the helping gradient descent. And yep, our approximating really better than with the linear approximating. And you can see changes and decreasing our loss function for every iteration. We can we started from 1.5, and we finished 0.4, and it's really good approximating for our squared function. Okay, it was case for linear regression, but where is logistic regression? For this code, we just consider Pytorch functions and abilities in Pytorch framework. Now we can use some function for write logistic regression from scratch. In this code, we loaded MNIST dataset. Tell me, please, do you familiar with the MNIST dataset? Dear students. Okay. We loaded MNIST dataset. It's a dataset with the alphabet images, and we want to classify A and B characterized. So the first class is B, and zero class is A. We discussed that our logistic regression model just linear lawyer with some nonlinear function. In this case, it's just sigmoid function. And you need to use NN point model from Pytorch. It's model for neural network classes. And when you want to write some neural network, you can use this module. And also in documentation Pytorch, you can find more detailed explanation how it works. And you can use it for different neural networks architecture. And in next lessons in this course, we will discuss, for example, convolutional neural network or recurrent neural network. I'm not sure that we will discuss recurrent neural network, but convolutional, I think, yes. And yeah, this framework you can use for different architectures. Okay, in official documentation Pytorch, I can, yeah, pytorch.org. My favorite is a tutorial from Pytorch. Oh, I think it's not. 1 second. Yeah, on official website Pytorch, we have part with tutorials. And in this part, you can see very interesting cases for using Pytorch in different machine learning tasks. And you can, yeah, this article really useful for you because in this you can find explanation about Torch NN class. It's really often using class. Also, you can find different neural network tutorials, for example, for computer vision task, for natural language processing tasks, and other. So I recommend you read this website. In this code, we want to create our logistic regression function. And as I said, we will use two layers. The first layer is linear layer, and the second layer is our non-linear function. So it's sigmoid. And you need just add layer 2 from layer 1, and yep, you give logistic regression algorithm. In this code, you create some dummy data for learning, for checking your model. And also, we will use cross entropy loss for our classification task. I think I need to give some information about cross entropy loss. It's a function that often it's really often a function for a classification task, and it looks like you have loss, you have a target value, and you have a prediction value. And your loss for a binary classification task is its target value multiply to logarithm your prediction value plus 1 minus y. It's your target value multiply log 1 minus predicted value. And why it works? Let's try to choose some value for a target. For example, y equal 1. And in our task, we predict that y equal also 1. So our prediction is right. And let's try to calculate this value. 1 log 1 is 0. So this part is 0. And if we calculate this part, 1 minus 1 is also 0. So our error is 0 because we predict the right class for our sample. But if, for example, our target equal 1, but in our model, we predicted that target equal 0. So it's incorrect class for our sample. And if you calculate value this expression now, you will see that our error limited to infinity. And it means that our prediction really incorrect for our sample. And you need to optimize this function. And yeah, with the gradient descent algorithm and with the Pytorch framework, you can make it and get optimal parameters for your model. Um, if we solve multi-class classification, your cross entropy loss, it's just sum 1 to k, whereas k is number of your classes, and y is real value for your sample, and log predicted value. So when you works with multi-labels classification tasks, you get output like some vectors, and first value is probability to get first class, the second value second class, third value third class, and etc. And for example, you talk that this value 0.9, it means that for a specific sample, probability to be from the first class is 90%. And you also know probability for other classes. And you just calculate errors for every classes in your data set. And you need to calculate this error for every sample and get final error for your model. Okay, let's go. In this code, you can write cross entropy loss manually with helping Pytorch function, but now we will use ready binary cross entropy loss from Pytorch. But I recommend you to try make it own without ready function. And I remind you that our to classificate A and B in MNIST dataset. So we choose some method for optimizing our model because we want to find optimal parameters for our model, and call backward function for adding new gradients in our model. In this code, you see number of samples in our dataset, and also you can see our predictions. So loss function shows our error in this model, and you can see that our loss decrease on every iteration gradient descent, and at the end we get little error for our model. If we want to estimate our model, and we want to estimate our model because we consider it metrics for a classification task. And I told you that when you solve some machine learning problem, the first task that you want to make it defining metrics of estimating your model, because you can create some perfect model, and it consists on many layers, and will very beautiful like machine learning model. But if you don't calculate metric, and don't estimate your model, and for example yeah, accuracy, and also metric for a machine learning classification task. But it's really simple metric, and it's just your right answers divide to all answers, and it's really bad metric for example, disbalance data. But in this case, you can use it, and we see that our model shows really good result. I want to say you some things about logistic regression algorithm, and to be honest, it's a really universal algorithm for different machine learning tasks, because you can see this algorithm like baseline in every task of machine learning. What I mean, when you want to classificate some images, for example, you want to classificate do you have a cat on this image, or we have some other animals, for example, um, I don't know, maybe rabbit. And it's also classification task. You can use logistic regression to define where is cat on your images from dataset. Next, it's computer vision topic. Next, you can work with natural language processing task. And for example, you want to solve problem of sentiment analysis. When you have reviews for some objects, for example, restaurant or book, or I don't know, some services, you usually have different appreciating from your users. For example, I really like this app, or I really hate this app, and etc. And you want to understand, is it positive or negative review? And to be honest, you solve classification problem. You want to choose positive or negative class, And for example, this your first class, and this your zero class. And you also can use logistic regression for making this task. How you can do it? In natural language processing and in computer vision tasks, you need to convert your objects in numbers. Because when you work with table data, for example, you have transactions. First, second, third, fourth, and etc. And you have some risk score for every transaction. For example, 10, 20, 5, 30, and etc. And you want to make a classification task. You work with numbers, and you can use some this model for solving this problem. There is X, it's your risk score, it's your feature. But in text data or image data, you need to get vectors for characterizing your data. And or maybe you know that image is just RGB data tensors, first, second, and third matrices with red, green, and blue values for every pixel. And when we work with text data, you can transform your text in to vector. How you can do it? For example, in natural language processing course, we discuss lots of methods for this task, but very simple methods for getting vector from text is one hot encoding. When you create vocabulary with unique words in your text, for example, I really like, and etc. You need to define all unique words in your data. And you just define vectors with one for this word, and other positions is 0. For this word, you define the second position like 1 and other 0. And analogical, you define all words in your vocabulary, and at the end you will get that for every word you have some vector with the one on position for a specific word. And now you have numbers, and with numbers you can make some operations and get some values in classification task. These vectors you can use in logistic regression algorithm. And in next notebooks, I show you some example with sentiment analysis with the logistic regression algorithm. I can show you how looks like dataset for NLP task. It's just text reviews, and for every text you have a label: positive, positive, negative. It's just classification task. Positive, it's the first class; negative, it's the second class or a zero class in our notation. And you want with logistic regression function to predict the right label for every text, for every new text. In this notebook, you can see exploration data analysis for this data set when we pre-processing our data and clear it, but but it doesn't important now. And I just want to show you how we can apply logistic regression to text dataset. Yeah, you see that we divide all sentences in token, and for every token, for every word, we want to get our vector, like one hot vector or some other methods for getting vector. And in this example, you use count vectorizer method for transform your text dataset. Count vectorizer, it doesn't important now what it means, but shortly is method really the same like one hot encoding, but more complicated but it doesn't important now. And in this part, you get vector for your words. If we get word, if we get of our vocabulary of our word, you can use logistic regression for classification your reviews. And yep, you just train test split your data on train and test parts. And you take logistic regression function, logistic regression model, and want to predict first and second classes, means positive and negative classes for your text, for your data. Accuracy in this case 81%. It's good enough, and I recommend you try to launch this notebook after our seminar, and maybe use different metrics for estimate your model. And yep, in here you just can see how logistic regression could be applied for text data. In this notebook, you can see some important information about logistic regression. I will send you this notebook in chat, and I think I'll add it in our useful materials for this course. But in this, you see our drawing, our images, to be honest, because yeah, it's weight vector, our matrix of features, BS, and in this you see sigmoid function for transform and for adding non-linear in our data. Yeah, it's just beautiful mathematic strings, and I'll send it for your reading. Task very simple in this notebook, and as I remember, we use only NumPy for realization logistic regression model in this notebook, and you can compare our implementation with Pytorch and implementation with NumPy, but yeah, it's just cool comparing for your education, but Pytorch is really cool. Okay, I think today maybe no. I think I told you all information, and I think we can finish our lesson. If you have a question, I can answer. If no, thank you for lesson. I can finish.
Can you tell us the grading for this course?
I think this information you can this question you can write in bot, because all information about graduating I haven't.
Okay, thank you.
Okay, thank you for a lesson. Have a nice evening.